Hi everyone, thanks for joining. Today we will explore Game of Prompts, or GOP. The main idea is summarized by our slogan, AI Challenges, Blockchain Solutions. GOP is a new platform designed to help AI development become more open and collaborative. It's built on top of two key technologies, Celaut, that is a system ensuring that services are unchangeable, immutable, and run in a safe, separate, isolated spaces, which is vital for fair and trustworthy competitions. And the Ergo blockchain, which provides a transparent system for rewards and verifying results when training and testing AI models. Celaut can also be used to execute services in a distributed manner, where the interaction processes also occur in Ergo, but this property is not relevant here in GOP. So today we use AI more and more, but its development is often centralized. This can limit broad participation, make it hard to see how things work, and hinder collaborative efforts. How can this be improved? How can more people globally contribute to solving complex AI problems and building better AI? These are the motivations behind Game of Prompts. So the main idea is to make AI development more like an open competitive sport. The system runs as follows. First, creators can define specific AI problems or challenges as game services. For example, a creator could design an AI challenge for the game Snake. And the game's service will be the Snake game itself, its rules, and how it measures the AI's score, like the Snake length. These game services provide the environment, any necessary data, and clear objective ways to measure AI performance. Then a global community of developers and AI enthusiasts can then create and submit their solver services. For the Snake example, this would be their AI designated to play Snake. So these solvers services run inside the game service. Celaut ensures that this happens in a way that is safe and isolated, protecting both the game and the solver. We will see this later on the demo. And finally, the scores, performance data, and price distributions are all managed transparently and fairly on the Ergo blockchain. So GOP aims to get more diverse and AI solutions by opening up challenges to everyone. It makes building and testing AI models more distributed, transparent, and accessible. So this platform isn't just about simple games. It's about building a framework to improve AI collaboratively with incentives for innovation. Let's look at the key components. So first, the game service. Think of this as the AI benchmark or the controlled test environment. It's a Celaut service. This means it's packaged so it cannot be changed. It's immutable once it's defined by the creator, and it runs in its own safe, separated space, so it's isolated. This is vital, so everyone can trust the test environment is fair and exactly as the creator specified, and it defines the problem, that provides the context, and includes the logic to evaluate any submitted AI model, any solution. Probably it will be executed by the participants on its own local nodes, and it's capable to do that. Second, the solver service. This is the AI model or algorithm created by a participant. It's also a Celaut service, so it's also immutable and runs in isolation. This ensures the game service can trust the solver hasn't been tampered with, and the solver is protected from excessive interference during the execution. It's their proposed solution ready for the evaluation. Then the GovWeb portal. This acts as the central hub. Creators can publish their AI challenges here, and developers can find these challenges, download game services, and later submit their results for on-chain validation. And it can be to a Celaut service or not. And finally, the Ergo blockchain. This serves as the highly secure and transparent ledger. It's used for registering AI challenges, tracking participations, cryptographically validating AI model performance, and distributing the rewards fairly. This structure, particularly with Celaut's immutability and isolation, ensures a trusted execution environment, allowing complex AI tasks to be broken down into verifiable and competitive challenges. Okay, so let's see what creators and players do. A creator who designs an AI challenge. First, they design the game or AI test. It needs a score that can be measured. It's also very important that the game has a variety or changes each time it's played. This stops players from just finding one fixed answer for a game that never changes. Then they generate a unique secret code for their game. This code is a key for securely verifying scores on the blockchain later. Then they package their game as a Celaut service with the inside, with the secret inside. Make it the service unchangeable. And finally, they publish it. They publish the service. This involves creating a game box on the Ergo blockchain, which stores a hash of their secret code, the competition deadline, the participation fee, and the service, the game service hash, and other parameters. And on the player side, the player is who builds an AI solution for that challenge, for that game. So the player first find a game and challenge on the Gov web portal and download the selected game service. The download can be done across the Celaut node if it's available in some peers, or in a centralized repository like Mega or Google Drive or something. Then they can design their solver service, their AI model or strategy. Also package the solution has an unchangeable Celaut service. Then they run the game service with their solver on their own Celaut node. Because they are Celaut services, they run in their own separate safe spaces, ensuring a fair test. When it finishes, they get their performance data, a cryptographic commitment, a list of scores, the real score is hidden among these, and a hash of the game logs. And if they are satisfied with their AI's performance, with the score, they submit their entry to compete into the blockchain. They do this by creating a participation box on the Ergo blockchain and paying the entry fee. Now, how are scores keep secret during the competition, but still proven to be correct and fair at the end? This is done using these commitments on Ergo. So let's explain it. First, when a player tests their game locally, the game service, which knows the game secret, the game secret is inside of the game service, generates a commitment. This commitment is a special hash code, like a digital fingerprint. It's made from the solver ID, the real score, the log hash, the game record code, and a secret game, the game secret. The player submits this commitment and a score list, their real score plus some decoys, to the blockchain. We use a list of scores because publishing the exact score directly could discourage later players from submitting their own attempts unless they were certain they could beat all the current scores on the blockchain. With this way, their actual score isn't public yet, but it's on the blockchain. So after the game's deadline, the creator reveals the secret code, and then the Ergo smart contract, the script on the game box, does the verification for every participant. It uses the revealed secret, their solver ID, their log hash, and tries each score in their score list to calculate the commitment. If this commitment matches the real submitted commitment in the participation box, the player originally submitted, that score is confirmed as the true and validated score for that AI model, for that solver. Then the contract automatically identifies the participation with the highest validated score, and that player wins. This entire process is transparent, verifiable by anyone, and enforced by the blockchain code. Okay, enough talk. Let's see how the system works. So first of all, we need to install the node, the Celaut node. So let's go to the node GitHub page. It's an alpha version, so this is important. If it's actually an alpha version, it's recommended to use a virtual machine. I'm not going to use a virtual machine, but it's recommended. So first we install this. Okay, so the node is installed. Let's check info. Okay, the key, yes. And we can see this is the address of this node, the commit version, and it's connected to a Ergo node. So, and was created two Ergo wallets. You can check how it works on the node documentation, but actually they doesn't have ergs. But this is not important for Game of Prompts. So first of all, we need to implement our game service. We have implemented it, but it's on games. This is our folder with the game service. So it contains all the logic to make the score, commits, and all of this. To manage the solvers, blah blah. So inside of the code, this is the secret that we should previously generate. So we are going to use this secret to submit the game service. First of all, we need to pack it into a Celaut service. So for that, we need to do node pack Ergo games snake and wait because this could take like 20 minutes maybe. So I'm going to break the video here. Okay, so the service game package process is finished. So we have the service on our Celaut node. We can check it with this command, or we can inspect with this other command. Here we see all the information about this service, the metadata, that is hashes, the hash of the service, the hash of all of this content, and the reputation proofs of the service that are on Ergo, but this currently doesn't have anyone. And here we see that the service can't connect to outside sources, so it can't submit information to other servers or something. So it's for privacy or things like that. So now let's, as game creators, we are going to submit our game to the Ergo blockchain. So we will need okay, well, no, this is not the browser. Yes, this. Perfect. Okay, so here we see the games, and we are going to create a new game. Snake demo video. The game service is this. We should add the type of the hash, maybe here. And our game secret that is in the code internally on the game service. So the participants can't see it because it's obfuscated. Actually, it's not obfuscated, but should be. Participation fee, we are going to put the minimum, and 2 hours, maybe. No, 1 or 2. The game creator will receive 20% of the total amount of ERG that is accumulated in the contract. We can put a link and snake and use an image, and this should be like the URL where the user can download the service game if his Celaut node can take it from other peers. So create a game. Okay, I'm submitting the transaction. Okay, so the transaction is done. Was approved. So here we have our game. This is the lifetime to the deadline, and I can submit my score. This is the same wallet that create the game, but could work too. So here we have the NFT of the game that the token that identifies the game, me, the creator. This is the service game, the game service. A link with more information, the participation fee, the creator commission, the stake that the creator puts on the contract to ensure that he will resolve it at the end after the deadline, and some URLs, a list of URLs that a participant could use to get the game service if the Celaut network can provide it, because maybe it doesn't have any peers with this service. This could be a centralized service provider, or like Mega or Google Drive or something, or EPFS, or a decentralized solution. So let's play now the role of developers. So now, as developers, we want to participate on this game. So we need to implement our solution that is here. This is there are two solvers, but actually we are going to use the basic solver, that is a very basic AI algorithm with if-else. It's very short. So the other one, it's a model language solver that creates a prompt to control the snake, but we are going to back this. So for this we need to do the same, this, and this could take 20 minutes too, maybe less, but we need to wait. Well, our basic AI snake, or robot to play snake, it's packet actually. Here we can see. So that means that packet means that we transform from the source code to a Celaut service. Okay, specifying the Docker file to create all the file system, specifying the interface of the service, and these things. You can read more about it on the Celaut project repositories. So now we need to close this. We need to play the snake game. We need to execute locally or in one of our peers the snake game. We have it actually on our node, but if we downloaded it from a mirror URLs, we should make this command import, like for example snake game Celaut v, and it should be imported to the node repository. So well, the node registry of service. So actually we have one peer, I think, that it's running in another computer of my local network. So we don't have X. This is the information of this node. I'm not talking very much about this, but each node has its own Ergo wallet. So they transfer X one to each other for rent gas, where gas is the representation of resources of a node. But yes, actually they can they give to each peer like a default amount of gas free, so they don't need to transfer ergs. Okay, so let's execute the node, the service game. Node execute snake game. So here our node has considered run execute the snake's game on the other peer, but this peer doesn't have the snake game service, so it will take from this node then, but actually it's running on our computer. We can read it here. This is the instance ID. The service is the snake game, and the parent is the client for that represents all the execution from the terminal, and the gas that has this instance. So we can access to this. So the snake game, it's exposing a simple web page to control it, that allows to play games, to play participations with other solvers, and to reproduce solvers from other participants later after the deadline, if they share their solvers logs of the game and game seed to a deterministic reproduction. So we need to get our solver with a Celaut B extension. So for that we need to export it. Export, what's the name? No, sorry. Here. So we export the basic AI snake. Okay, and actually we have this on the desktop, so we can run this the game. We load it on the game service and start live game. So actually the game service is receiving the solver, our solver, in a file using a library, a Celaut library, that allows a service to interact with its node. The game service will be able to request the execution of the solver to the node that is executing it. If you're interested on how Celaut works, or how Celaut manages services or things like that, you can check the demo videos that are on the Celaut repository. GitHub repository. Okay, so we can see actually that the game service has sent the solver to the node, and the node is building it. Building it means that it's taking all the file system and creating a virtual machine for that service. But this is only needed at the first execution of a service in a node. Okay, so actually the node it's running actually the solver. So we can check this, checking the instances, grow, pet. So actually the both services, the game service and the solver, are running on the local node. This can be seen where? Location. Here in location. But if the other peer of my network will take this the execution here, where my node says, okay, where I should execute this, and it's only considering the itself because the other peer doesn't have the service. But and as we can see here, the game, the snake game, the game service loses some gas, spend some gas to execute. Our solver has dependency. And yes, so this game snake game, the game service, it's execution. It's controlling, it's executing the solver service. So here we can see the progress. So the for each time the game service sends the state of the snake and the environment to the solver, and the solver returns a position like up, down, blah blah blah. This time was only length 3. It's a low score, but it's valid. And this is the seed of this game. We need this to allow reproduction for other participants to check our solver if they want. Here now we need to download this participation data. We could replay it more times. The solver can get to a 50 score or things like that, but we are going to participate with this. So here we need to download the data packet. So this contains all the information that we need to add to the Ergo blockchain. It contains the solver ID, or solver ID, that is this. The hash logs, that basically are all the logs, this log file that is here. Okay, this contains all the information about the game. This is the commitment that contains internally the secret, just the game secret that only the game creator knows. And this is a score list where this is one of them. It's a real one, and these other actually these parameters are not going to be loaded to the Ergo blockchain, but should be in other versions of the protocol. This is the seed for reproduce the game, and indeterminism index says to the others how many times you need to reproduce to the solver to get the same logs. Okay, so for this example, for this solver, it's very deterministic. So, but if it's a model language, for example, solver, probably it needs a more height index. Maybe. We can modify these scores if we want, but it must contain the real score, because if not contain the real score, the contract will not continue, will not add our participation on the code. So okay, we can download this, and we are going to submit a participation with this data. So okay, 30 minutes only. I have made I have repeated some parts of the video, so okay, submit my score. So I can put all the input forms manually, or submit a JSON file. Downloads, yes, this. So here is the commitment code from that contains the service, the service secret, the game the hash logs, yes, the hash of the logs, the service ID, the score, the real score. This is the solver ID, hash logs, yes, hash logs and scores, where this is all real, but other participants will not know. Confirm. And we need to wait now to this. So we can reproduce if we want the logs here. This play, and we can reproduce our game, for example, or we can play another time if we want. Okay, so the transaction is confirmed. So our participation was submitted. Okay, there's one participation and there are 22 minutes left. Okay, so this is our participation. We can see the score list, but the real it's encrypted, and there are this amount of ergs to the price. So we are going to stop the video and resolve the game after the deadline. Well, so after the deadline, the participation is closed. So now the participants need to wait that the game creator resolve the game. Because for resolve the game, the game secret is needed into an output of the transaction that will spend the game box and all the participation boxes. So has the role of game developers, the game creators, are going to take the secret that is inside of the game service. We are going to resolve the game. So this transaction, the script of this transaction will loop all the participations and all the scores of each participation and select the correct score for each participation, and will allow send the prize to the participant with the highest score. So okay. Okay, the transaction is done. It's completed. So we can see now that the status is that the game was resolved. So, and this wallet is the unique participation and is the winner. So we received the transaction with the ERG. And yes, and we can see here the real scores of each participant, and that's it. That's everything. So why is Game of Thrones good for making AI better in the future? Well, it ensures fair and trustworthy AI test. The rules are code. A model performance is only openly validated, and prices are given out by smart contracts on Ergo. Changeable and isolated services are key for this trust. So everyone knows the game and the AI players are running exactly as designed without hidden modifications. It rewards innovation when prices are given for the best AI models. It encourages people to try new approaches and find breakthrough solutions to AI problems. It fosters decentralized collaborations. Ergo provides the trust layer for results and payments. Game of Prompts can help break down traditional silos where AI work might be stuck with one group or in one place. It opens new kinds of AI challenges. The platform can host competitions for AI models in many advanced areas, like algorithm trading in simulated markets or scientific discovery, like protein folding, for example, or complex resource management problems, like, for example, energy optimization or on installations, or I don't know. There are a lot of challenges that can be done, and it empowers both creators and developers. Creators can design and monetize unique AI challenges, and developers get a platform to test their skills, gain recognition, and potentially earn rewards from their innovative AI models. And then the AI models that are shared between the community are open, not source open, maybe could be, but not necessarily. But they are isolated pieces of software, so anyone can use in its own local computers or other computers, but without the censorship resistance of other AI solutions where are hosted only on the developers' servers. So, as we say in the last slide, the Snake demo is just the start, because Game of Prompts is designed for a much wider range of AI applications. I'm going to enumerate some of them. AI learning to navigate and control things, like more advanced version of Snake game or Pac-Man or other retro games, or but can be to simulated robots in complex environments, complex and simulated environments. And then these same solvers can be executed in real robots in the real world. For example, algorithmic trading bots, where AI agents compete for achieve the best returns in simulated financial markets. There is an example of trading game implementation on the code base too. We could have scientific discovery AI challenges for tasks like protein folding or discovering novel material properties. AI for strategic planning or resources optimization, games that test an AI's long-term decision making. AI for making or fixing computer code, where AIs write the book or optimize software if the rules of these challenges are well specified. And natural language processing task, where AI are scored on their ability to understand, interpret, or generate human language. That is the trending topic actually in AI. So if an AI's performance on a task can be quantifiably scored, and if its environment can be built as a Celaut game service, it can be a Game of Prompts challenge. Okay, so vision and future plans. So the first version was built for ErgoHack. The first version was built for ErgoHack, showcasing the main idea. Looking ahead, the vision of GOP is to make it a significant platform for advancing in AI in a new, open, and truthworthy way. So for that, I'm going to enumerate some points that could be necessary or important. Group the community. The aim is to attract AI researchers, developers, and organizations to both create compelling challenges and submit innovative AI solutions. Develop advanced game mechanisms and AI evaluation metrics so the platform can support increasingly complex AI tasks. provide better tools to simplify the creation, testing, and deployment of game and solver instances. This is more a task for the Celaut part, so the Celaut layer maybe, but and explore possibilities like multi-chain support and integrations with other AI platforms to expand reach and impact. Particularly, the multi-chain support can be it's more detailed on the documentation of the ErgoHack proposal. You can read it if you want. So basically, this opens a big opportunity for a worldwide incentivized and transparent platform for fairly making and testing AI models. So that's Game of Prompts, a challenge blockchain solutions, the slogan. It's a platform designed for people to compete, collaborate, and advance AI in an open, distributed, and trustworthy manner. So thank you for listening, and I'm happy to answer any questions on Discord, Telegram, or the YouTube comments of this video. So thanks.